Hey everyone, today's video is about Fugit I already mentioned him twice in my videos. This time it's about a comment he left in a thread. Load of bollocks, light like water cannot bend. What we see is reflected light, blah blah blah. Well, light cannot only be reflected, it can also bend due to refraction and diffraction. Let's talk about all of that a little bit more in detail. I try to keep it simple. We all know what reflection is. For example, if we stand in front of a mirror and shine a narrow beam of light at it, we get a narrow beam of light reflected back off it. This is called specular reflection. Most objects aren't smooth and highly polished. They are quite rough, so when you shine light onto them, it's scattered all over the place. This is called diffuse reflection, and it's how we see most objects around us. The only reason we can see them is because light, either from the sun or from something like an electric lamp here on Earth, reflects light off of them into our eyes. Now we talk about diffraction. Diffraction involves a change in direction of light waves as they pass through an opening or around a barrier in their path. Like water waves, light waves have the ability to travel around corners, around obstacles, and through openings. Diffraction occurs with all waves, including sound waves, water waves, and electromagnetic waves, such as visible light, X-rays, and radio waves. A way to make it visible is a double-slit experiment. No flat earthers, this is not a threesome, it's an experiment in which a light wave is split into two separate waves that later combine into a single wave. Changes in the path lengths of both waves result in a phase shift, creating an interference pattern like this. Now we come to refraction. Light waves travel in straight lines, but that changes when they travel through different materials, especially when they move from air through another, more denser one. They slow down quite dramatically. This tends to make light waves bend, something we usually call refraction. Here you can see a refraction experiment with a laser pointer, water and sugar. The water on the bottom is more dense due to the sugar than the fresher water above. This slows down the beam as it moves through it. Another example are my glasses. They work with refraction too. Eyeglass lenses are curved pieces of glass. The curvature of the lens bends the light rays. This helps the rays focus on the retina instead of behind or in front of it, like it does if you're short-sighted or far-sighted. Refraction also happens in our atmosphere. Normally, light waves from the sun travel straight through the atmosphere to our eyes. But light travels at different speeds through hot air and cold air. The effect that this creates is called mirage. Fata Morganas, an inferior mirage for example, happens when the ground is very hot and the air is cool. The hot ground warms a layer of air above the ground. When the light moves through the cold air into the layer of hot air, it's refracted. A layer of very warm air near the ground refracts the light from the sky nearly into a U-shaped band. Our brain thinks the light has traveled in a straight line and comes from something on the ground. Another mirage that almost everyone has seen himself is heat haze, which you can see when you look at objects through a layer of heated air. For example, looking at distant objects across hot asphalt. Distant objects appear to shimmer because of slight differences in air temperature that affect the transmission of light to our eyes. And we have of course the famous superior mirage that confuse so many of the flat earths. They happen when the air below the line of sight is colder than the air above it. This happens mostly over large bodies of water or ice. The apparent direction of the mirage will be opposite to an inferior mirage. For example, the distorted image of a skyline may appear on or above the surface, even if the original object is hidden below the horizon. All of this is not new science and not at all magical, so I don't know why flat earthers have such difficulties to understand that. I leave a few links to super easy experiments about bending light that you can do at home for yourself in the description. And with that we reached the end of today's video. Thanks for watching, bye bye and stay tuned.